In the last stream, we were working on setting up this system over here from the replication mod to allow us to break down different items into their matter values and then reconstruct those matter values into really anything that we like, but specifically the item that we need to replicate the most going forward is going to be this unstable matter, which is made by combining together 12 of each of the different types of matter that are available. Now, right at the end of the last episode, we did put down this AE2 replication bridge to allow our applied energistic system to communicate with all of the replication blocks over here. And at the end of the last episode, it wasn't really working. However, since the end of the last episode, we have had a pack update. And so now back over here, not only can we see all of our matter in the system, but you'll see there that we can also request something like unstable matter if we have what it takes to make it. Now, at the moment, we actually don't have everything. We're missing some quantum matter. But for example, do I have what it takes to make a diamond? I do, because we have 36 precious matter inside of that system. If I click start, it's going to go ahead and produce a diamond for me through that replication bridge. Cool. So what I've gone ahead and done between episodes is I've gone ahead and moved the metal press that was over here previously, and there's our diamond done. Fantastic. Not that we necessarily want to be able to craft diamonds with the replication mod, but it's good to know that that link does work so that going forward, we can potentially use that link for unstable matter. But over here, I've gone ahead and moved the metal press because going forward, I do want to put down more of these ME pattern providers. And in fact, real quick here, I'm going to go ahead and request a few more ME pattern providers and a few more molecular assemblers as well, because the pattern that we're going to go with is something like this. It's a fairly straightforward pattern that saturates a full ME Fluix cable. So the idea here is that we have 8 ME pattern providers down with an equal number of molecular assemblers in a 2x2x4 pattern. So I have moved these since the end of the last episode, but currently we do have the same number of pattern providers and molecular assemblers that we had at the end of the last episode. The only difference here is that we're going to put them down like this, with molecular assemblers here, here, and one more pattern provider like that. So this has exactly 8 pattern providers with exactly 8 molecular assemblers. If you wanted to, you could also go ahead and put down even more molecular assemblers kind of around the outside of these pattern providers. This system here kind of maximizes the number of molecular assemblers touching each pattern provider. So each pattern provider has access to 3 molecular assemblers and vice versa as well. And this is just a nice kind of modular setup because we can run one Fluix cable. It doesn't have to be dense. And if I want to set up more, I can put another one down right next to it and get even more patterns available. Moving our metal presses over to here has made space for that and has also allowed us to set up more metal presses because this is going to allow us to automate the crafting of all of the gears, plates, rods, and wires that we want going forward without having to do it manually every single time. So I have gone ahead and wired all of this up. These guys are getting power and these pattern providers are connected up. And so it should just be a case of, for example, teaching our system how to make, let's say, a steel gear like this. As per usual, get rid of the gear mold and encode. We can then place that into this pattern provider like so. And then we have a few options when it comes to taking the outputs here. We could put down a chest at the end of all of these and then put like an importer on every chest. I was also contemplating using ender chests, putting an ender chest at the end of all of these and then having one centralized ender chest that we could then import from. But what we can actually do here, if we get some logistical transporters, it turns out that these metal presses can actually export directly into a logistical transporter like this, and if that logistical transporter were to then connect up to an interface, all of the items that are produced will then get piped around back into that interface. We don't necessarily have to do it on both sides like this, but just for the sake of symmetry, I am going to do something like that. And so now, if I were to go ahead and request, let's say 10 steel gears, I think this should just work. And look at that. It totally does. It doesn't look like it connects at the end there, but the metal press does kind of shoot the item into the pipe, and then the pipe sends it round into the system, and that is gears automated. Alongside the metal presses here, I have also gone ahead and thrown down 2 ME pattern providers above our alloy kilns, And this actually leads us into what I want to work on in today's stream, because now that we have access to unstable matter, we should be able to make the nuclear reactor here from the Techopolis mod. This is a very large multi-block structure that's going to allow us to produce both polonium and plutonium kind of indirectly through nuclear waste. So the idea here is that we can put any one of these radioactive ingots into the nuclear reactor. The nuclear reactor will then, over time, burn those ingots, producing a decent amount of power, depending on which ingot we burn, as well as a different amount of nuclear waste. That nuclear waste is then used in the production of plutonium and polonium, which are both necessary for progression forward because we need them to make antimatter. Antimatter here is made using antimatter liquid. The antimatter pellet, that is made using antimatter liquid, which is made by combining both the polonium and the plutonium in a nuclear reactor. And so to get started with that, we do need to build this nuclear reactor, which is going to require a ton of reinforced machine casing because, as I mentioned before, it's a very large multi-block. And so I figured it was probably in our best interest to teach our system here how to make that reinforced machine casing, because not only is that going to make it easier for us to build this reactor, but this reinforced machine casing is also used in a lot of other multi-block structures, like our dimensional ore extractors downstairs that I think we are going to end up making more of in the future. And so getting this out of the way kind of sooner rather than later, I think is going to be very useful. So to make this isn't really too difficult. It's wooden scaffolding. Teaching that is kind of the easiest part of the whole process here. We'll also go ahead and teach the wooden gears as well. Both of those can go into any one of our generic pattern providers over here. Let's do this and this. We did teach our system previously how to make the teleportation core, so that is already good to go. Teaching it how to make the teleportation dust should just be as simple as placing this in here above the crusher, and then as for the actual machine casing, that of course needs to go in over here. Now, we do also, in that case, need to teach our system how to make the obsidian ingots, which is of course why I have this pattern provider over here. I do think if we wanted to, we could tweak the blocking mode, and we could, in theory, do both crafts with one alloy kiln, but I think that's just kind of going to make this more convoluted than it needs to be, and more importantly, it's going to make the system slower than it needs to be as well. And so instead, what I'm going to do is I'm going to make another pattern that teaches our system how to make the obsidian glow ingots. That one is going to go in over here, and then from there, we just need to teach our system how to make both refined obsidian, which we can do in the osmium compressor. For this, I am going to go ahead and just teach the system to send the resource and not the osmium. We're going to do something very similar to what we've done with our infusing factories here, where I think we're just going to continually export osmium to the osmium compressor, as opposed to trying to send osmium to the osmium compressor whenever it's needed. So I'm going to quickly kind of shimmy these around. That way, we can just place our next pattern provider down directly on top like this. We can then, of course, point that down, and in here, we can drop both of these patterns, and then from there, if we grab one more export bus, we can throw that onto the back of the osmium compressor, and with that, we can go ahead and kind of hook that up, and just tell it to continually export osmium. Making sure, of course, that here the top is set to purple with auto eject on, and that the side connected to the ME export bus is set to extra. We have run into a slight problem here, and that problem is channels. So of course we only have 8 channels coming from our regular Fluix cable here, and with this setup we've gone from having exactly 8 items. Before we had 5 pattern providers and 3 export buses. Now we have 6 pattern providers and 4 export buses for a total of 10 items. And so what I am probably going to do here then is kind of tweak this a little bit. So we can go ahead and connect this guy to this cable that we have down here. That's the same cable that's going to connect over here. There are only 5 of these, so having a 6th one there is completely fine. And then over here, that's still too many items if we're connecting all of the pattern providers together there, but that should actually be fine. What we can do is we can run another cable from our dense cable. Let me quickly check that we're good on dense cable channels. We could definitely do with a smart dense Fluix cable here, just so that we can see how many channels are being used on this side. We're only using 9 currently, which is actually fine. And using some of the cable anchors that we made last episode, we should be able to, for example, kind of not connect here, but then run a cable that goes up and connects to all of these, bringing all of these online without saturating the channels currently being used by the other cable. And so once this is connected with cable anchors preventing it from connecting to any of the other cables, these are now all online and should be ready to go. So now all we need to do is connect both of these up to the network as well via some more Fluix cable in the ground, and we should be able to just request the reinforced machine casing. And with those connected up, we should now be able to request the reactor casing. We can. Our system doesn't know how to make sticks of all things. Thankfully, that is a very easy craft to teach. We can do something like this, actually, and teach it how to make 16 sticks at a time, which I think is definitely the more efficient way of doing that. And of course, we can just throw those into any one of our pattern providers. And then looking at the nuclear reactor placer, this tells us that we need 86 reactor casing, as well as 72 reactor glass, 68 reinforced machine casing, 32 machine circuitry, 4 reactor control rods, 25 machine vents, and 28 reactor fuel rods to make this nuclear reactor. And so in terms of the casing right here, we need 68 reinforced machine casing. Can we make 68? In theory, we can. We'll hit start there. Things are going to start kind of moving right away here. This is fully upgraded, which is good. We could always make this into a factory, I think, as well, if we wanted it to be even faster. Hopefully we'll see things over here working as well. We totally do, and we even see that machine casing being made. Nice. Over here, we have gone ahead and thrown down 2 advanced logistical transporters. The idea is the same as with the metal press. We're just going to extract from here, ideally not in wrench mode, so that we can pump the items back around to the pattern provider, thus putting them back into the system. And so real quick, I am probably going to go ahead and teach the system how to make a couple of the other items here. Things like the machine circuitry, again, is something that we've made before and isn't too difficult. It's made with 2 calculation processors and a reinforced machine casing. This is the kind of recipe that we should be able to just put directly above our general purpose inscriber, which is very quickly filling up in terms of how many patterns are inside of it. But I'm going to go ahead and teach our system really as much as we can for this nuclear reactor and then see if we can't request the items required. Real quick, this doesn't work straight away here because by default, the input slot stack size is set to 64. I think if we change this to 1, this might work. So real quick, in here, you can click crafting status and we can cancel this craft because it's not going to get done. But if I go and try that again, that totally works. So if you leave it to 64, it will just put both of the calculation processes into the first slot. But if you set it to a stack of 1, it will actually go ahead and do the craft. All right, so I've gone ahead and encoded patterns here for the steel casing, the reactor casing basic, the reactor glass, the reactor control rod basic, the machine vent, the iron bars, which are required for the machine vent, and for the reactor fuel rod basic. I believe that's all of the items listed on here, so we can go and throw those into one of our pattern providers, so long as there are channels available, which it looks like they are. This one here is offline. I think that's because I'm currently pulling from here, and you'll see that we're using one channel right here for this export bus, and so we should either run like a different channel or upgrade part of this to dense cable to make this work. But either way, there's nothing in here currently, so that's not a huge problem. But that should be everything available to request. Before I do request it, there is another multi-block structure that we're going to need to set up, and that's in the previous quest line. We need to get at least 1, but potentially 2 reprocessors here. So the reprocessor is another fairly large multi-block. It's not quite as big as the nuclear reactor, but the idea here is that we can use the reprocessor to turn our cyanite into plutonium. We can then use it to turn the plutonium into ludicrite. We can then use it to turn the ludicrite into radiculite, the radiculite into enanite, and then the enanite is used in the making of ultimate technium ingots. The reason we only need 1 of these is because we should be able to use a different reprocessor controller on each side of the multi-block. So the picture here just shows it on the one side, but we should also be able to put one in front here, and in front here, and effectively get 4 different reprocessors with one structure. That would allow us to do the making of plutonium and ludicrite and enanite and radiculite, all 4 of those with the one multi-block. However, it's also quite possible that we might want to get a 5th process going, that being the conversion of uranium into cyanide. We are currently doing that conversion downstairs with our basic reactor, but going forward, the basic reactor, I think, is going to prove far too slow for the speed that we want. And so if we want to be able to make that cyanide faster, I think it's going to be quicker to turn uranium straight into cyanide using that reprocessor. And so if we want to make 2 reprocessors, we need 2 lots of 16 machine circuitry, 12 reactor glass, 30 reactor casing, 44 reinforced machine casing, and 9 machine vents. The good news is that all of that stuff is shared with the nuclear reactor. And so real quick, I'm going to go ahead and request enough of all of these to ideally make 2 reprocessors and 1 nuclear reactor. Okay, so we've almost immediately run into a hurdle, and that hurdle is that our 1K crafting storages here are not anywhere near big enough for the crafts that I'm trying to do. We could do the crafts in smaller batches. For example, here I do need to request 126 more reactor casing, and if I try 126, it's over the 1024 bytes that we have available. We could just lower this to 100 and then do 26 later, and that would work, but I think it's going to be in our best interest to just upgrade these to be larger. If I'm not mistaken, I think you can take the 1K storage component out of these and reuse the crafting storage. Not that we necessarily need to. What we should just do is go ahead and request, let's say, 2 64K ME storage components so that we can actually make 2 64K crafting CPUs, thus giving us more than enough room for the crafting that we're going to need for at least the near future. To do this, we do need to get some glowstone, which we currently don't have, and I think we're also going to need glowstone quite a bit going forward as well. And currently, I believe we have to make glowstone using nickel or zinc in the purification chamber. And of these two, nickel is currently the only one that we have coming in automatically. And so I think what we're going to want to do here is get yet another pattern provider, throw that down on top of our purification chamber, like so. That still is fine from a channel perspective. We put down specifically 8 machines so that we could connect all of these up on one cable. In here, it should just be a case of teaching the system that glowstone can be made using nickel dust. We are almost certainly going to have to teach the system how to make nickel dust as well in the crusher. Thankfully, that's the easy part of the recipe. Throw you in there and throw you in here. And then just like before, I guess we probably want to just go ahead and export enriched flint to the back of the purification chamber to make sure that it always has oxygen available. And now, if we do go ahead and request those 64K drives, it should go ahead and make the glowstone and then pump it back around into the system. Okay, so this is now way faster. We've put in all of the upgrades, including the chemical upgrade, and I have taught my system how to make the enriched flint as well, using the enriching factory, and so now the glowstone is coming in way faster, and of course, as soon as we have 2 64K storage components, we can then go ahead and request 2 more of the crafting units here. Those should come in fairly quickly, at which point we could then either add or replace the 1Ks. For now, I'm just going to go ahead and replace them, so I'm going to swap these out directly with the 64K versions here and here, thus giving us even more crafting capacity. I think, if I'm not mistaken, you can, shift right click to get the 1K storage components back out of those crafting units, and so later on we can use both the storage components and the crafting units to upgrade to higher tier crafting storage if we need even more in the future. But now I should be able to go back and request all of the crafts for these two without storage being a problem. Alright, so I think we have basically everything that we need here. The machine circuitry, I believe, is done. So I think everything is good to go. I've grabbed some tech books out of the system because we need to go ahead and purchase both the nuclear reactor placer and also the reprocessor placer. Cool. Once we have both of those, I'm assuming that we do need both the reprocessor and the nuclear reactor as well to actually put the multi-block down. So for the reprocessor, we just need some cyanide, 6 reinforced machine casings, and another elite technium machine frame. Right now, we do have a little bit of elite technium lying around, and so that should be somewhat doable. We're just missing a diamond gear. This is probably the perfect time to go ahead and teach our system how to make the diamond gear using our new metal press automation. We can, of course, just whack that in over here. Boom. And so with that, I should be able to go ahead and request the diamond gear, at which point the reprocessor will be makeable. And then as far as the nuclear reactor is concerned, it's kind of the same thing here. We do need to get another diamond gear. Let me request another one of those. I feel like I might as well just go ahead and teach our system how to make the elite technium machine frame, so we have those ready to go as well for the future. And then we do need to get one more unstable matter. there has been a change to the quest that I saw between updates. So right here, it says, I'm sure you want to spend a lot of time trying to find the perfect combination of ingredients to make this without waste. The next page provides an option. So here, the quest book tells us that 3 leafy string, 2 blocks of nether wart, 2 uranium ingots, 2 iron bars, 1 diamond, 2 crates of ender pearls, and 2 compressed cobblestone should give us all of the matter required to make unstable matter. So for us, currently, I don't actually think we're too far away. We are just missing a little bit of quantum, which I believe we can get from our massive reserve of ender pearls here. We probably do want to pivot this back to making ender pearls. I think this should be more than enough simulation pearls for the time being, and of course we can always get more of them in the future should we need them. So if we do one of these, that's going to get us more quantum, and as soon as we get up to 12 quantum, we should then be able to just go ahead and request another one of the unstable matters here and start, at which point this is going to kick into gear and begin making that for us. And once we have our second unstable matter, that should be the reactor good to go. In terms of the reprocessor, now that we have that diamond gear, we can make this and this. We did teach our system, I probably should have just requested it, but there is our reprocessor. We are going to need a lot of these actually, and so we should probably also just teach the system how to make the reprocessors, because I think we're going to need at least 4 more of those. I'm going to hold off on requesting those until we have the nuclear reactor, which we should now be able to make. Boom and boom. Cool. So let me go ahead and request a few more reprocessors, and hopefully our system can kind of work on those in the background. Whilst that does that, down here, let's see if we can't make this happen. So our nuclear reactor is a 7x7 multi-block that is quite tall. Not so tall that we can't fit it down here, though, I don't think. So it might actually kind of fit perfectly here. So I've placed this down, I believe, centered between these two, and if we right-click, shift right-click, we get our nuclear reactor. Cool. Okay, I might end up pushing that back a little bit, but for now that is going to work. And then I think opposite to that, we can throw down our reprocessor. I am going to put this one, 1, 2, 3, 4, 5. I'm going to put it right here, like that. We're missing 11 basic reactor glass. That, thankfully, is kind of the easiest part of the equation here in terms of getting more of. Boom. Cool. So this should now kind of be good to go and ready to work. And of course, as we get more of the reprocessors, the idea here is that you can put these down like this around the multi-block. And because the multi-block is kind of perfectly symmetrical on all sides, all of these will work independently of each other. They don't interfere with the working of the other multi-blocks, and then we just need to build another one of these next to this to allow us to do the 5th craft, that of course being for the cyanide. And not too long later, we have everything for our second reprocessor. And I've hooked these all up to power, but I think I'm actually going to tweak the way this works, and I'm going to set up a mini little XNet system here that I'm going to use just for this setup, because I was kind of having a think with the Twitch chat about how we're going to go about moving each of these ingots from kind of one side of the machine to the next, because here we're going to turn uranium into cyanide, then we need to take that cyanide round to here to turn it into plutonium, then we need to take the plutonium round to here to turn it into ludicrite, round to here to turn it into radiculite, and then round to here to turn it into the final form, which is the anandite. And while we could do that with these logistical transporters, it's going to look a little janky if we have kind of pipes running all around like this, and then energy cables sent to the bottom and trying to insert and extract from different sides of the machine. It's doable, but I think it's going to look a little bit janky. And if we instead kind of just disconnect all of these cables that we've connected so far, we should be able to connect everything up to just the XNet controller and essentially use this as a small, localized XNet system to move everything to where it needs to go. So, for example, over here, we can put XNet connectors really just onto the bottom of all of these, because we can also use this XNet system for moving power as well. So let's do this, 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 and this. I've also made a bunch more of our XNet cable, so we can kind of connect all of these up like this, and then we should have connection here via this connector to our energy cable. And so we do, of course, as we did before, need to put a connector onto the bottom of the controller itself. Let's connect that up here, and then we'll also run that cable over and around to this guy as well. 1, 2, and 3. So now in here, We might need to give this power to kind of kickstart it, so we might need to do something like this, somewhat awkwardly, to get power in there. But once it has just the tiniest bit of power, what we should then be able to do is create an energy channel, extract from any one of these cables, and insert into the connector. And so now it's pulling power from one of our universal cables to power itself. And then from there, we are going to have to use an exporter to export to the first reprocessor. So we'll go ahead and craft one of those up real quick, and we'll throw that down, let's say right about here. This one is going to connect up to our pre-existing dense cable, which is right about here. So let me quickly request another 32, maybe, Flux cable. Perfect. Once that comes in, we can run that over to here and tell this to export uranium. And so the uranium is going to be continuously sent over and into here. Now, in here, we do need to get water. And most of these recipes require water, at least the first half. The second half require purifying water. We do have both of those being made, and our water is currently actually in our ender tank over here. And so we should be able to just grab another ender tank to allow us to pull the water down. And then we can also probably do the exact same thing actually for the purifying water as well. If we get another 2 ender tanks, we could replace one of these with an ender tank for purified water that we're going to have on a different frequency. And then from there, we could just put down here 1 ender tank for purified water, 1 ender tank for regular water, and again, use our little mini XNet system here to send the water and purified water to the correct reprocessors. Okay, so I've gone ahead and crafted a few more of these ender teleportation cores using our ender storage blueprint. And so now we should be able to craft 3 ender tanks here. We also are going to want to get some diamonds as well and some lapis that we can turn into blue dye so that we can go ahead and set these to the right frequency. So down here, I'll put all 3 of these down. We're going to set one of these to blue, blue, blue and lock it. That's our water frequency. We're going to set these 2 here to purple, purple, purple. And then we'll lock both of those as well. And if we go ahead and just kind of swap out one of these, ideally trying our best to not break XNet cable as we go, which is always easier said than done. Let me recover that up. We can then take both of these down to our new little system, and we should be able to just hook them both up with XNet connectors. So let's do, I might actually put them just kind of like here and here. If we put one connector there and one connector there, we can do purified water here and regular water there. And then from there, we can set up a new channel for fluids, create, we'll call this water, and then we just want to extract from the right one, which is this one here, extract, and we're going to insert into the right reprocessor, which is one of these. You can double click on the block in here, and it will show you in the real world, it'll highlight it. We want that last one, this one right here, is the one we want to send it to. So we'll set that to insert. There should start receiving water. It totally does. And then now that water is going to allow this to turn the uranium into cyanide. It's just pretty slow at doing it. It's way slower than I thought it was going to be. That's fine though. So then let's make another fluid channel here. We'll call this one purified. And here we're going to go ahead and extract, of course, from the other tank, and we're going to insert into the other processors. So I think what we want to do here, I could have probably done with naming these so we know which is which. In fact, let me do that real quick because we've got a lot of work to do here and it's going to be easier if we know what's what. So this is going to be for plutonium. This one here is going to be for the ludicrite. This one over here is going to be for the radiculite. And then the final one here is, of course, going to be for the inanite. So now, back up here, I believe that the first 3 tiers need water. So that's the reprocessor over here. That one's currently the one making cyanide. We'll name that one as well, just for consistency. And so the plutonium wants water. The ludicrite, I believe, also wants water. It totally does. And then these 2, the inanite and the radiculite, both need purified water. Cool. Then we need to start going with the item channels here. So we'll create an item channel. And here we're going to extract the cyanide from here. I don't think we need to filter it, but just to be on the safe side, let's go ahead and say that we want you to extract cyanide, and we're going to insert that here into the plutonium. And hopefully, if that's working correctly, we should see, look at that, cyanide being moved over into the correct machine. Then, of course, we want another item channel here, create. Here we're going to extract from the plutonium, and again, we don't necessarily have to whitelist it, but just to be safe, we'll do this, and we're going to insert that into the ludicrite. Boom. So that should put the plutonium in over here. And it did. Cool. And so from there, it's a little bit slow, but we're going to do the same thing again. We're going to take the ludicrite here. We're going to set this to a new item channel. You get the idea. This one's going to extract, and then this one here is going to insert, and then we'll do the same for the final one here. We'll create another item channel. This one is going to extract from the nanite. Oh no, that's not correct. I want to insert, these are not quite in the right order. Let me get rid of you. You want to insert here into the radiculite, and then here we want to extract from the radiculite and insert into the nanite. That is the correct order. And so it's going to take a minute for all of these to actually kind of do the job that needs to be done, but it should eventually kind of just work, I think. Again, we've not filtered those last ones, but they shouldn't need to be filtered because there's nothing else being extracted or inserted on this same channel. And now, using this flux cable, we can hopefully kind of complete this system and have fully automated the process of turning uranium into a nanite. And boom, we'll put the uranium into the exporter. And so now that should just continue to fill up with uranium. It does say not enough energy, and that's of course because we need to set all of these to insert on energy as well. That is my mistake. They all had some residual energy from when they were first connected up, but setting all of those to insert should allow the XNet system to fill all of those up with power as well. And look at that. In the time it took me to facade all of this up and get our uranium exported, we've made 3 nanite. Now we do, I think, want to get like at least one of each ingot to complete the quest. I don't know if it's strictly necessary at this very moment in time. Like, I don't think we have to complete these to progress, but we definitely should complete those just to get them completed. But now, the nanite, I believe, is actually the best ingot that we can put in the nuclear reactor. You can put really any of the ingots that we just mentioned into the nuclear reactor. You'll see here that the uranium produces 2,560 Fe per tick and produces 1,000 millibuckets of nuclear waste. But then as we go up, we produce even more power, 7,680 for the plutonium, slightly less for the cyanide because it's an earlier part of the chain. But all the way at the top is the nanite, which produces 20,480 Fe per tick and produces 12,000 millibuckets of nuclear waste, both of which we do want because we need that nuclear waste, as we said earlier, to produce the polonium and the plutonium using both the solar neutron activator and the isotopic centrifuge. So before we do this, the nuclear reactor here can only hold 50 million Fe, and each one of these produces 24.5 million. So in theory, actually, we can put 2 of these in here, and that's not going to quite overflow the reactor. We might want to look at some kind of mass energy storage. Right now, I have mentioned it before, but we do have a lot of energy capacity. We've got 1.5 million, at least, in our basic universal cables. That was a lot earlier in the pack. Currently, though, going forward, it's not really going to be that much, especially when we start looking at the production of antimatter pellets, because this right here requires a staggering amount of redstone flux. I think millions of redstone flux are required to make these antimatter pellets, and so we are definitely going to want to look at some large energy storage so that we can make sure that we're storing all of the energy created from this setup right here. Before we do that though, let's see if we can't get the solar neutron activator and the isotopic centrifuge, because those are going to allow us to make both the polonium pellets and the plutonium pellets, which eventually are going to be used for antimatter. But before that, we can actually get started on this ultimate Technium quest line, which is going to allow us to start working with the extended AE mod, which is going to make our AE2 system just that much more powerful than it already is. So to make the isotopic centrifuge is super straightforward, actually. It's one basic chemical tank, and then lead we already have, and ultimate control circuits our system can make, and so we'll request those. That shouldn't take too long. The solar neutron activator is a little bit more expensive. It requires some reinforced alloys, some elite control circuits, bronze ingots, advanced technium machine frames, and then the trickiest bit, I think, is this one HDPE sheet. The reason that the HDPE sheet is tricky is that it requires a bit of a chain to make. So you need 3 HDPE pellets inside of an enrichment chamber to make one HDPE sheet. Each HDPE pellet is made in a pressurized reaction chamber with oxygen and liquid ethene. The liquid ethene is made from a rotary condensator from the gaseous version of ethene, and to make that, we need water and hydrogen with biofuel in another pressurized reaction chamber. Okay, so I've made 2 pressurized reaction chambers and 1 rotary condensator. Looking at the HDPE sheets, I don't really think we're going to need these for much else later in the pack. So I don't necessarily think it's worth kind of fully automating this. Instead, what I think we might do is kind of just temporarily power these. Let me check where our nearest available power cable is. And the answer is not really anywhere convenient. I could put these down here, I guess, for now. If we do this, this, and this, I think we could just use a combination of chemical tanks here to move some stuff around. For example, we have both hydrogen and oxygen in here, and so we could just go ahead and do something like this and kind of temporarily pull some hydrogen and oxygen out. The same is true for the biofuel. We already have some of that made, and we could also siphon some more off from downstairs as well. And so in here, the first step is to do water and hydrogen. Water, of course, we can just grab one of our buckets and go grab some water manually from any of the tanks that are available. Now, annoyingly, I don't think that you can just book it into mechanism machines like this, unfortunately. I think we might have to pipe that in. What we can do, though, I think we can just put the tank in for hydrogen, which is this one. Nope, that also doesn't work. Okay, that is fine. Let me grab some pressurized tubing, and let me grab one of my mechanical pipes. So it's going to be a little bit janky, but it is very temporary. Let's do this. Let's set you to extract like that. That's going to fill up with water. Let's do something like this and get the chemical tank down for hydrogen, like that. We'll, of course, go ahead and set that to extract. That should put both of those in there just as soon as we make sure that the chemicals are set to input from the front. Oh, and I completely forgot, in here, you also have to set the chemical tank itself. It doesn't act like a regular tank here. This doesn't have a configuration, but this does have a side configuration. Let's make sure that's set to output. Now that's moving over. We can put the biofuel in, and that's going to make us some substrate. We then need to get 3 substrates so that we can make 3 HDPE. We also need 150 millibuckets of the liquid ethene as well, which is made as a byproduct here. And thankfully, it's being auto-pumped into the rotary condensator. We might need to do more than 3 substrate just to get enough of the liquid ethene. Thankfully, that is being moved right over, and actually, it looks like we're kind of completely fine here. Let's do the exact same thing here. We'll throw you down, set the side to output, put down another one of our basic pressurized tubings, set that to extract, and that should get us all of the HDPE that we're going to need. And once we have the 3, perfect, we can then use this to go ahead and make us the HDPE sheet in our enriching factory. Cool. And that should be kind of everything to make the solar neutron activator. Everything else is requestable, and our system should have that made in no time. Nice. So now that we have both of these, we can, first of all, go ahead and kind of just pick up everything here. I don't think, like, we might as well do one of these real quick. I don't think we're going to need more than one solar neutron activator, but on the off chance that we do, I'm going to go ahead and just kind of let this run for a second, and then we'll just kind of pick up everything else kind of as and when it's done, so it's no longer needed, and we're not going to leave it here. But now downstairs, we should be able to start using these to make both the polonium and the plutonium. So this is where we need to be very careful, because both polonium and plutonium are radioactive. You'll see here that when we hover over the liquid, it says radioactivity is 20, whereas water isn't radioactive. And the same is true for the polonium as well. This one's even more radioactive. Basically, if that escapes into the atmosphere around us, our base will become irradiated and we'll just start to die immediately, which is not great. There are things we can do to kind of mitigate that. Up here, there's a quest to make the radioactive waste barrel, and then there's a quest to make the Radaway machine. The idea here is that the radioactive waste barrel is able to store nuclear waste, because the nuclear waste here as well is radioactive. You'll see there it says 10 MSV per H. That's also 10 radioactivity units. And basically, if it's inside of a machine, it's fine. If it's inside of a pipe, it's also fine. But, for example, if you were to break a pressurized tube that had radioactive waste inside of it, then the radioactive waste would leak out and things would get bad pretty fast. So we just need to make sure that we don't let that happen. And so we need to make sure that we pump directly into these machines. So what I'm going to do is, I guess I'm going to do something like this. The solar neutron activator is a little awkward in that, as the name suggests, it does require the sun. Like, it requires, I believe, access to the sky in order for it to actually produce power. And so we are going to have to do something like that. I'm pretty sure, though, that that should work. So now, if we go ahead and set this to extract, that's going to pull the nuclear waste out of there and put it into these two machines. The good news about the solar neutron activator is that it's very fast with its solar power. The isotopic centrifuge, on the other hand, is not so fast. So again, this is where we need to be very careful, because if I break this machine, that nuclear waste is going to go everywhere and things are going to be bad. The same is true over here. We also have another problem, and that is that because I made the isotopic centrifuge with a chemical tank that had hydrogen in it, this is full of hydrogen. The good news is we can take that out, and if we are, again, very careful, we should have an energy pipe just over here that we can run to that isotopic centrifuge. Cool. So now that's going to go ahead and make the plutonium, and then from there, all we need to do is run those both into a pressurized reaction chamber with water. The good news for us is that we have exactly 2 pressurized reaction chambers right here. So I'm going to do a quick one of those just to make a bit more HDPE, even though I don't really think it's going to be strictly necessary. And then we can go ahead and pick up all of these. Perfect. And we can use those PLCs downstairs to hopefully produce both the plutonium and the polonium. Now, these both are going to produce another byproduct, I believe, and that is spent nuclear waste. Spent nuclear waste is also radioactive. I believe there are 2 options that you have here. You can either pump that spent nuclear waste into a radioactive waste barrel, and you'll see here that this says actual decay rate is 1 millibucket per 20 ticks. What that means is that if you put a radioactive element into here, so if you put nuclear waste or spent nuclear waste into this barrel, it will slowly but surely decay over time at a rate of 1 millibucket per second, which is not particularly fast, but is the kind of safest way to get rid of this. Alternatively, in this pack, what we can do is we can put the spent nuclear waste into this Radaway machine to turn it into safe spent nuclear waste, which I assume if we wanted to, we could then just put into like a fluid trash can and delete. However, I'm fairly certain that if we press U again, this is actually required for the making of ultimate Technium Ingots. So we actually want to store this safe spent nuclear waste so that we can use it in the production of ultimate Technium. So let me see here if we can't get this show on the road. If I put you here and you here, we are going to have to do some reconfiguring, and I'm very careful about breaking stuff near here, especially given how fast our Paxel is, but we are going to have to go ahead and kind of reconfigure these pressurized reaction chambers, because right now they do still have stuff in them. I believe that we can get a gauge dropper from Mechanism, and that's going to allow us to take the gases or liquids that we currently have inside of the PRC and take them out. For example, over here, if I do this, we can take the oxygen out, and I don't know if there's a way to dump that. There is. You can just shift right click. Cool. We'll do the same here with the ethylene, dump that out, and then over here we can do the same with the water, dump that out, and with the hydrogen, dump that out. Cool. The water is necessary, actually, now that I think about it, but this needs to be set to output to the left. Auto eject on, you need to be set to input on the right, like that, and hopefully that's going to receive the gas, of course, just as soon as you set it to the right tab. Perfect. Okay, so these do both need water, and even though this little XNet system was really only intended to be used for the reprocessing, what we could do here is we could go ahead and actually kind of repurpose both of these, and if we instead just use a little XNet connector kind of here and here, we could then connect both of those up to the pre-existing XNet system and use it to provide it with both power and water. So once that's connected up, it should just be a case of making sure that both of these are set to insert on the water channel and that they're both set to insert on the energy channel. And now both of those should be ready to go, and they totally are. So now the final piece of the puzzle for the polonium is flow rate, and for the plutonium is also flow rate, actually. That is fine. Currently, we, I think, do have some flow rate in the system. We've got a very small amount of it. We can go ahead and take one of these for each machine to make this work, but we could definitely do with automating the production of that. Now, I think, if I'm not mistaken, that me holding these items will cause me to become irradiated, which is where the hazmat suit comes in. The hazmat suit here, I believe, prevents us from taking radiation damage whilst holding something like the plutonium or the polonium. To make it, we need lead and then orange dye. Orange dye we do have, actually. I didn't think we did, but we do have a bunch of orange flowers, and so we should be able to quickly whip up the hazmat mask, the hazmat gown, the hazmat pants, and the hazmat boots. Cool. We'll go ahead and throw those on. Taking these off is going to get rid of our speed effect for now, but what we should be able to do is now grab both the polonium and the plutonium, completing both of those quests, and now in the ultimate Technium section of the quest book, we should be able to look at starting to make entro seeds, because these entro seeds here are made with just 4 polonium pellets and 1 unstable matter. Of course, as I mentioned a second ago, we do need to kind of deal with the spent nuclear waste. And so before we go any further, what I'm going to do is I'm going to quickly get even more unstable matter so that we can make the radioactive waste barrel. We need 6 of them to make a radaway machine. It's a lot, but it's necessary, unfortunately. So we are going to have to get like 24 unstable matter, which should be pretty doable. All right, so a fair bit of matter disintegrating later, and we have almost everything that we need here. You can see we have 22 unstable matter worth of matter inside of our system here, and I've been breaking down a bunch of different stuff. The trick with the disintegrator is to break down things that are compressed. So for example, cobblestone on its own is 2 earth per cobblestone, but if you craft that cobblestone into compressed cobblestone and then craft that compressed cobblestone into double compressed cobblestone, each one of these does give you 162, which is just how many cobblestone it took. The reason that this is beneficial, though, is that it takes the same amount of time to break down, whereas trying to break down all of that cobblestone individually would take a much, much longer period of time. The same is true with things like wool. It turns out you can craft compressed wool. This gives you a ton of living and a ton of organic, and you can just kind of throw these in. The same is also true with the ender pearls here as well. You can craft 9 ender pearls into a crate of ender pearls, which gives you a bunch of ender, a bunch of quantum, and even more organic as well. And so just where possible, it makes things a lot quicker if you can compress things down using blocks of ingots instead of regular ingots. Anything like that you can do just makes it way faster, because the disintegrator itself is not particularly quick, especially if you're trying to process a lot of items. For now, though, we do have the ability to make 22 of these, which is not quite all that we need. I am missing just a little bit of glowstone. 288 is the magic number. We only have 270 nether here. I did go ahead and request like 500 glowstone from our system, 540. It's been working its way through that, and we've been kind of throwing it in here as time goes on. I'm going to go ahead and request 24 of those. They should be placed in my inventory, at which point we should then be able to go ahead and make this radaway machine. We do also need to get 2 ultimate chemical tanks, which, as before with any other kind of ultimate tier item, it's probably going to be easiest if we just teach our system how to make the regular tank, then teach it how to make the advanced tank, and then of course the elite and the ultimate, at which point we can just request those tanks be made for us, and we don't have to spend the time microcrafting each and every one of those individually. Boom, and ultimate tanks. If we want to make the radaway, we just need 2 of these. Back over here, the replicator itself is also not particularly fast, so it is going to take a little while to bring all of that in. That should be fine, though. Once we have the unstable matter, actually making the radaway machine should be pretty straightforward. We can, of course, go ahead and request a diamond gear here. We are kind of running into a bit of a problem, and that problem is that we have little microcrafts like the, enriched diamond, enriched flint, things that are being used over here to keep things going. Those are being requested here, and then here we've got the glowstone craft, and so we've kind of run out of CPU space. We do, of course, have the crafting storage from earlier and the 1K crafting components, so it's probably actually not a terrible idea to just quickly throw these down. Now, the place that I've chosen there, apparently, is a place that already has cable. It is. I'm going to reroute that cable just to the bottom side so that I can put down another 1K storage here and another 1K storage here. That's just going to allow us to do more than 2 auto crafts simultaneously. And hopefully, yeah, these smaller CPUs can handle smaller crafts, so that when I want to go ahead and request something like the diamond gear here, we should have CPU space available to make that happen. And once we have 24 unstable matter, I am going to go ahead and request the other 9 here and click replicate, just so those are getting made in the background, because we do also need to make those to make these entro seeds, which we are going to need momentarily. For now, though, we should be able to take these and make 6 of the radioactive waste barrels, and then we should be able to upgrade those to the radaway machine. Just as soon as our system makes that elite Technium machine frame for us, and boom, cool. So that completes that quest, and as we saw earlier, we should now be able, downstairs, to take the spent nuclear waste that we have and run it through the radaway machine to kind of clear it all up. So I'm going to put it here, and then using some more pressurized tubing, which we do not have but can go ahead and make, we should be able to kind of run the spent nuclear waste kind of round into here like this. Let's just make sure that as far as chemicals are concerned, the output is set to the front with auto eject on. That's going to push that out. Fantastic. Same over here. Chemicals, output, auto eject on. That's going to go ahead and pump the spent nuclear waste into here. And then from there, it looks like we just need to connect this up with power. Again, very carefully. And again, I might as well go ahead and just use the XNet system because we have it here. It's easier than running fresh power cables over for that machine. Let's just make sure that this guy is set to insert. This has run out of power somehow, despite the fact that this is set to insert. I'm going to set the priority higher on this. I'll set it to 5 so that this always gets power first. It's possible that all of the power that was inside of one of our cables was sent around to one of the other machines first, or that I misconfigured something here, but I feel like that should always receive power. Again, giving it a higher priority should just make sure that it always gets power before anything else does, which is kind of necessary. And then in here, this guy should hopefully also start receiving power, although it looks like we're actually just not producing enough power. Seems to be the problem. This guy is losing power whilst it's making stuff, and so that's probably the reason why that's not filling up. Interesting. Temporarily, I'm going to set this to a slightly higher priority. We'll set it to 1. Whoops, to 1, so it should receive power before anything else here, and that should then go ahead and start making safe spent nuclear waste, which is good. For now, I guess we'll probably look to storing that in a tank. I'm probably going to go ahead and quickly just teach our system how to make the higher tier tanks as well, so that we can maybe request just like an ultimate fluid tank. And so once all these are taught, we can go ahead and click start. That's going to go ahead and hopefully fairly quickly make us an ultimate fluid tank, which can hold 256,000 millibuckets of the spent nuclear waste. And right now we have, I think, nowhere near that much available for us. Let's have a look. In here we've got 2,000. So we've got quite a while before it really becomes a problem for us. And so for now, at least, we'll do this and we'll do this. Can I really not extract that? Or is it it might be a gas. Interesting. If it's a gas, it means we need to request an ultimate chemical tank, not an ultimate regular tank. It is indeed a chemical, so it's on in the chemical tank. Perfect. Okay, so we have an ultimate chemical tank. The good news is this can hold a ton, 8.192 million millibuckets, and we only have 2,000 here, so this is going to go for quite a while, and of course, eventually, we can start taking this and using it to make ultimate technium. The good news now is, I guess we can kind of solve our power problem by just connecting this guy up to the power grid. Now, we might actually, at this point, begin to run into actual power problems in that we are going to be producing way more than the theoretical 3,200 RF per tick that this can handle. As I've kind of shown off before, that's not always kind of how that works, but for now we'll leave it how it is and we'll see how it plays out. If we need to upgrade the cables, we can of course do that fairly easily with some alloys. That is already pulling power from there, so all of these should have a decent amount of power. We are going to lose some power here by putting these in because we don't have the storage for it, but I do want to start getting more of the polonium specifically. So real quick, what I'm going to do is I'm going to go in here, I'm going to turn the input side to off. So I'm going to turn this to none for now. That should hopefully prevent anything from coming in here because right now I want to get more of the polonium pellets because the polonium pellets are what we need to make these entro seeds. We need 4 of them in total. So hopefully some of the spent nuclear waste here is going to go round through into here, and then we can just put some of the fluorite from the system into this PRC to make us more polonium pellets. And then we can combine those polonium pellets with the unstable matter that we requested upstairs to start making the entro seeds. Never mind, it turns out you cannot waste power with the nuclear reactor because it looks like the nuclear reactor just does not work if the energy storage is full. So if we really want it to be wasteful, there is an energy trash can that we can make that will just delete energy, but it's probably in our best interest to look at actually storing that energy for later use because the antimatter is going to be so useful for us. So the normal way that we would do this is potentially with an energy cube. The energy cubes for mechanism just act as energy storage. The highest tier one, though, can only hold 102 million FE, which is only twice as much as the reactor. And so that's where the induction matrix from mechanism, which is a big multi-block structure, or I should say a configurable multi-block structure, comes into play. Because the idea here is that you can make a structure really as big or as small as you like, and depending on how many of the induction cells and the induction providers you put in, determine the capacity and the transfer speed of the multi-block. So you basically build a custom energy cell. And thankfully, I don't think it's going to be too hard for us to set one up. If we teach our system to make the induction casing, this is the main wall of the multi-block. We can also teach it to make the induction port. This is how we put power in and take power out. We can also teach the structural glass. This is, I believe, an alternative to the induction casing. You can't put it in the corners. It's kind of like the reactor that we built downstairs. You can put this in the walls of the induction matrix so you can see inside. And then from there, it really depends on how much capacity we want. Because you'll see here that you can get pretty big capacity with even just a basic induction cell. This one right here has 3.2 giga FE, which is 3.2 billion FE worth of capacity. The basic induction provider here determines how fast you can pump in or out. The max rate on the basic one here is 102,000 FE per tick, which I believe is more than fast enough. The tricky part here is that it requires lithium dust. However, we do have lithium being produced, and in fact, I'm pretty sure we also have lithium dust. We do. Cool. So that should be pretty straightforward. Our system does need to know how to make energy tablets in code. It also needs to know how to make basic energy cubes, which is going to require the teaching of advanced Technium machine frames, which for now is going to require the teaching of the advanced Technium nuggets. We definitely should look at swapping out the drawers that hold our Technium for compacting drawers, so we don't have to teach it this. For now, though, if we come over here, we should be able to kind of throw these in like this, and we are very close to running out of space again in here. This one is still missing channels. I do need to still kind of reroute that. Are all of these completely full? They are indeed completely full. And so real quick, let me do some cable management down here. If we just kind of swap out this cable here with a bit of dense cable like this, that should immediately rectify our problem and give this the channels it needs. It does. Perfect. So we'll throw you in there. And then, if I'm not mistaken, the basic structure that we need isn't going to be very big. So let me see about requesting some induction casing. We'll make the smallest one we can for now, which I believe is a 3x3x4. And so if I take like 20 of these, they're going to come in very fast thanks to that lithium. Let's also go ahead and take one induction cell. We'll take one pair of ports. It's going to make both of those at the same time. We do need to make at least one induction provider, which I guess we can actually just go ahead and request. We don't necessarily need to teach that just yet. We'll take you, and then we'll also request some of that structural glass as well. This should be pretty straightforward. We're going to have to find a more permanent hub for this in the not-so-distant future. For now, though, I'm going to, as a proof of concept, kind of build it right about here. So the idea is that we can throw down something like this, and I believe that the edges and the top and the bottom do need to be made out of induction casing. We might have to get like 7 more to fully complete this. I'll request 10 more just so we have a bit extra. But the idea is that we can use the structural glass in the walls, like this. Some of those are, of course, going to have to be power in and power out. For now, we really only need power in. We don't necessarily need power out, but we'll put 2 in either way because we have them ready to go. And then inside of here, we've got space for 1 induction provider and 1 induction cell. And so now if I finish this off like this, it should form into a multi-block, and you'll see here that we now essentially have a battery that can hold 3.2 billion redstone flux. And if I'm not mistaken, we should be able to do something like this, and it's going to start storing the energy from here inside of this cable. It's at this point where it's probably well worth doing something like this to go ahead and upgrade these cables. And not only doing that does seem to pop off the facades, but doing that allows us to extract from here just that little bit faster. If we get a few reinforced alloys as well here, we can upgrade these kind of one more time just to make that even quicker at moving the energy out of here and over into here, which is perfect. It means we shouldn't have too much downtime on that reactor. And going forward, I think upgrading this is pretty straightforward. One of the big questions I do have is actually whether or not breaking and moving this kind of deletes the energy. If I request some more induction casing, and if I request another basic induction cell, what we should be able to do is just take that induction cell and kind of make this bigger. So if we were to break this, and again, you don't need to break these, you could leave them as casing, you don't have to put glass here, but we'll do this just to make it look right. If we do that, and if we grab this guy, putting this in is effectively going to double the capacity of our induction matrix. And it looks like that did retain the power. Whether or not the power is retained and you actually break the block, like if you break the induction cell and move that, it might lose its energy. Although, actually, let me take a look here. It does say here, stored energy 0 out of 3.2 billion, and some of the other mechanism machines, no, never mind, look at that. It totally does retain the energy inside of it. That's really nifty. This one's got 74, this one's got 12.46. And so you could even go one step further, actually, and I believe you could maybe even upgrade these to a higher tier, and they would still carry over their energy. For example, if we did something like this and taught our system how to make the advanced energy cube like that, and we put both of these in over here, boom, boom, we could probably go ahead and request 2 of those. If we put you and you in there and request 2 of these next, and copper gears, that is actually completely fine, because of course we can now go ahead and quickly teach our system how to make copper gears using the metal presses from earlier. Let's throw you in right about here. Cool. And then let's try that again. I want 2 of these next and start. That should use the 2 that we have, and I believe that the 2 advanced induction cells that we get should have the energy that was already stored inside of those pre-existing induction cells. And these ones are way better, by the way. They kind of scale up quite nicely. These can hold 25 billion Fe each, and so we're going to have a total of 50 billion, and you can make this multi-block structure quite big. This is a very small one. You can make this really large. I think that the maximum might be something like 17 by 17 by 17, which gives you a ton of space for a ton of induction cells. And of course, you can do the same thing with the providers as well. If we get to a point where we are producing, or we need to send out more than 100,000 redstone flux per tick, we can always go ahead and either add more of the induction providers or upgrade it to a higher tier. For now, though, if we do this and we open this up, you'll see we do not have the energy. It looks like we did actually lose that energy. That's because it made 2 new ones. I see. Okay, right. So it didn't use the ones we already had. It decided to make 2 fresh ones, which means, in theory, I guess, what we could do here, if we wanted to maximize the efficiency and actually utilize the power that we have, we could do this, and it's going to look bizarre, but you can mix and match the induction cells that you put inside of here. And if we do something like this, that's going to allow us to use the new induction cells and the old induction cells to give us a total capacity of 57 billion redstone flux, and that should be more than enough for us to keep this running for quite some time. Over here, this is slowly but surely working on producing us the polonium. We currently have 3. I've also been told that apparently we don't need the hazmat suit. I'll keep everything apart from the legs here, because the legs are going to allow us to run. I think usually you do need the hazmat suit, but I think it's one of those things where if the polonium or plutonium says that it's radioactive, as in it has like the little text that says radioactive on it when you hover over it, then you need to be wearing the suit to hold it. But if it doesn't say it, then you don't have to, and currently it doesn't say anything, and you'll see that I am completely fine even without those leggings on. And so, hopefully, any second now, once this completes, we should get another polonium pellet, which should then be everything we need to get this Entra seed. And boom, there is our polonium pellet. Let's go ahead and combine that up with our newly minted unstable matter, and if we do something like this, we can get our Entra seed. Then begins the ultimate section of the quest book here, and the idea is that we can right-click the Entra seed onto a Fluix block to create a budding, fully Entroized Fluix. So Fluix we do have, and we can go ahead and of course craft that into a Fluix block. From there, sometimes you can craft this. Here we can't craft this, but what we can do is we can put this down and right-click it with the Entra seed. From there, what's going to happen is it's going to start to slowly but surely grow these Entra crystals, and then we can harvest those Entra crystals once they're fully grown and use them to make Entra dust in either the Crusher or the Inscriber. Those can then be used to make these Entra ingots by combining them with gold and lapis, and the reason that we want these is, for one, they're needed to make the ultimate Technium machine frame, so we do need 6 of them to make this, but they're also going to allow us to improve the inscriber situation that we currently have over here, because right now, if we look at, for example, our calculation processors, this requires an inscriber with 1 printed calculation circuit, 1 printed silicon, and 1 redstone to make 1 calculation processor. If we get the crystal assembler here, we can turn 4 of each into 4 calculation processors, and it's just way faster. On top of that, if we want to make more printed calculation circuits, currently we're using a Certus quartz crystal with a calculation press inside of the inscriber to make the printed calculation circuit. And it works, but it's a little slow. However, with the circuit slicer, we cut the calculation press out entirely, and we can just turn one block of Certus quartz into 4 printed calculation circuits, which again is just way faster. Both of these, though, do require these extended machine frames, which you guessed it, require the Entra-infused ingots. Now, before we actually make this and put it down, I am going to go ahead and teach my system, I think, to make the growth accelerators here, because these are going to allow us to massively increase the speed at which the Entra crystals grow. So let me encode that. I think basically everything else there is taught. We might also have to teach it how to make Fluix blocks as well, because I don't think those are currently stored in a compacting drawer either. And in theory here, we want quite a few of these. I'm going to go for 4 to start with. That shouldn't take the system too long to make. And these we can just connect to our AE2 system to provide them with power, and then we're going to point them at the Fluix block. So again, temporarily we'll put this down, I think, somewhere over here. We do need to find a more permanent location for it, but if we were to do something like this, let's say, and then if I were to do something like this, we need to kind of put the growth accelerators down like this so they point at the Fluix block. If you put them down just like this, they don't point at the Fluix block, and so they're not going to work to increase the growth speed. So what we want to do is kind of do something like this, and then it's going to look real awkward, again, hence why it's somewhat temporary. But if we do something like this, these don't use channels, because all we're doing here is just providing these with power. And once these are all online, which they are, we can then go ahead and right-click the Entra seed onto here to begin the growth process. Now, it's at this point that it could also be worth us getting some kind of fortune enchantment onto our Paxel to give us even more Entra crystals when we break the crystal that grows. And just like before, we can do that with molten lapis. How much lapis do we have? The answer is actually not a lot of lapis, but the lapis is coming in automatically, of course, and we do have a decent amount of lead, so it should be completely fine. So over here, if we go ahead and melt down some lapis, we should just be able to throw our diamond Paxel into here, which does have space for up to 3 more modifiers. And then it might take a fair bit more lapis than this, because we need 1,350 per level, but we can get up to 5 levels on this, which I think is going to make our Paxel very good at getting a very large number of Entra crystals every time we break one of these blocks. And not too long later, this should be the 5th and final fortune setup. It is perfect, and thankfully, 1 full controller worth of lapis is the exact right amount, so you just have to do that 5 times. And so now over here, what we should see is when we right-click this, the growth accelerators are going to make this grow way faster than it normally would, and then we can use our new diamond Paxel to hopefully get more than 1 crystal from every cluster that grows. So this is fully grown, we break it, and we got 2. I was hoping we might get like 3, but 2 is fine. This does deteriorate over time though, so every time you break it and you start growing new ones, it is going to slowly wear down this crystal. You can then fix it using a crystal fixer. That's this guy here. The crystal fixer is not very fast though, and to make the crystal fixer, we do first have to get the crystal assembler, and so we are going to have to get like 8 Entra-infused ingots before we can make both the crystal assembler and the crystal fixer. So I do think that we are just going to have to kind of sacrifice this budding block here. It will eventually just turn into a block of Certus quartz, although we do have 10 here. And so if I were to crush these, from there we should be able to grab some gold and some lapis, which we actually already have, as well as the Entra dust that we just made. I don't actually know if we have any water kind of down in the base. I don't think we do. That, of course, is a very fixable problem. If we do something somewhat awkwardly like this, we can then throw in the Entra dust, the gold, and the lapis, and then get out of there before our magnet kicks in, at which point we should see a bunch of Entra-infused ingots being made. The crystal assembler here requires a skystone tank, which is fairly straightforward by the looks of it, as well as an ME crafting terminal. It looks like we are fully out of power here, which I was not expecting. Thankfully, that should be fine. All we need to do down here is make sure our configurator is not in wrench mode. If we shift right click this, we can change it from input to output, and then from there we can just go ahead and run this kind of round to our basic universal cable. That should allow our system to tap into the power that's in here if it's needed, and you'll see it is using it. It's pulling the power from there, which is good. So now back up here, let me see. We should be able to make the skystone tank. We can. And then what else do we need here? I can request the processors. The extended machine frame is pretty doable. We're going to need 2 of those, so I'll make both of those right away here. And then from there, we just need to get an ME crafting terminal, which I was hoping would be easier. Again, we can request the processor there, that's fine. As far as the ME terminal is concerned, we can of course go ahead and request that as well. Let's do one of these into one of these into the crystal assembler. Nice. Again, for now, this just needs power somewhere, which you can give it by connecting it to a Fluix cable. And so in here, if we wanted to make the crystal fixer, we just need some Certus quartz, which we have, with 2 quartz fiber and 1 extended machine frame. So the extended machine frame we have, and the quartz fiber we do also have. Perfect. So let's go boom, boom, and boom. That should somewhat slowly, because we don't have any acceleration cards, make us the crystal fixer. It's a little too late for the crystal fixer because, as you'll see, this has broken, and we didn't actually get the block that we wanted. But the idea with the crystal fixer is that we can place it beneath the block, beneath the budding block that we're trying to fix. And if we provide it with, I believe, ender pearl dust, it's then going to go ahead and slowly but surely fix the block. So let me see here if we can kind of show this in action. If I put this here, we should then be able to connect that to the cable beneath it. Again, I don't believe it's going to use a channel. I think it's just going to get power from that. Then we want to get another Fluix block that we're going to put right about here. Then the tricky bit is getting another one of the seeds, because the seeds require more polonium. Hopefully down here we have more. We've got 1, and we need 3 more, which means I have to put even more of the nanite into here. One thing we haven't done that we definitely could do is we could look at getting an elite machine frame, because I believe we can make this nuclear reactor faster if we go ahead and put this guy into here. Yeah, that should make it like 60% faster than it was before. Again, not strictly necessary for the power production. In fact, could be a net negative for the power production. It looks like we're just about holding steady now in terms of how much we're producing versus how much is being extracted and stored in here. Eventually, we'll all end up in there, but I'm mostly interested in getting more of this nuclear waste. Of course, this only works when the night falls. Also, it looks like this didn't work earlier. I was hoping to not... Oh, that's because that is what we want to set to none. There we go. Okay, so now, before we had stuff being set to here, which was causing a bit of an issue for us, now everything should be sent to here, which should produce more polonium for us and should allow us to get even more polonium pellets. Of course, it is nighttime currently, and believe it or not, the solar activator does not work at all when the sun's not out. And once we have 4 more polonium pellets, boom, we can get another Entro seed. And so, as I was saying before, the idea here, I believe, is that we can put ender dust into here, like that. We're probably going to want to teach our system how to make ender dust, and we're probably going to want to set this up in such a way that it's continually exported as well, so we just always have ender dust being sent around to here, which should be fine because we're making it automatically with our hostile neural networks system. But I believe now that if I right-click here, we will put down maybe one of our growth accelerators. The problem that we're going to run into, if we put down too many growth accelerators, is that it's possible that the budding block kind of decays faster than the repairer can fix it. And so I believe if we wanted to, we could also maybe point multiple crystal fixes at the budding block. For now, though, if we do something like this, and then we right-click it, I've put these here just to stop the crystal growing on multiple sides. It's going to grow more slowly because of the fact that we only have one growth accelerator pointing at it and not multiple. But I'm hopeful that that's not going to be a problem for us. I'm hopeful that this is going to allow the crystal fixer to kind of repair it faster than it decays. We've got 29 ender dust in here right now. I'm going to keep an eye on that to see if it actually uses any ender dust. I think once this fully grows and we break it, that's when we might see this number go down. Let's break you. That gets us more Entro crystals. So I've broken 3 more clusters here, and we have 14 Entro crystals now, and you'll see that we're still at the budding fully Entroized Fluix. So it's still at the same tier it was before, and so I think this is sustainable, and it actually hasn't used any ender dust yet. I'm going to assume that ender dust will go down over time, but the only thing to do now is to maybe look at using something like an annihilation plane to automatically break this for us going forward, but I think this should be pretty sustainable, and we should now be able to use these Entro crystals to, of course, look at making the ultimate Technium machine, because here we only need actually 6 of these, and so to be fair, I think we should be able to kind of crush what we have. If we go ahead and grab the dust version, we should then be able to, of course, break our ice. Let's do you, and you, trying not to pick it up with the magnet. Perfect. And that should be pretty much everything that we need for the ultimate Technium machine, just as soon as our system makes for us the elite Technium machine frame. Boom and boom. Nice. And so next time, chat, we'll come back, we'll look at setting up this multi-block structure on our fourth and final overworld platform here. And then from there, it's of course just a case of automating all of the resources here to actually make the ultimate Technium ingots, some of which we've kind of already done. The inanite is already coming in. The replica blocks are not too difficult. The cyanite plates are also not too bad. We have cyanite from our reactor and we're making it automatically as well. Antimatter, of course, we're going to have to work on by automating unstable matter, and we're going to have to use the polonium and plutonium to make antimatter here, which might require another nuclear reactor because currently we're using one to make the spent nuclear waste. We need another one to make the antimatter liquid here. And of course, we are going to have to automate the polonium and plutonium, which we've not done yet, which is going to require the automating of fluorite. But I'm pretty sure all of that should be pretty straightforward for us to do. And I am quite happy that over here, this does seem to be working. It looks like we're going to stay at the budding, fully enterized fluix block, which means we don't have to keep spending more unstable matter and more polonium on making more of those in the future. I do want to move this, of course, to a more sensible location. The same is true, of course, for the induction matrix as well. I kind of want to move that to a more sensible location. And I'm not really happy with the position of this reactor either. I think we might also look to moving that to somewhere else, especially, of course, if we're going to build a second one of those as well. But that is all something that we'll work on in the future, because for now, I'm going to go ahead and wrap up this episode of Techopolis 3 there.